Looking up at the night sky gives us a sense of comfortable routine. We see the same patterns and cycles, making it easy to feel like we understand our cosmic neighborhood. The sun dominates our daytime sky, yet it is a medium-sized star, no different from the lights we see at night, except for its proximity to us. Even our closest neighbor, the moon, behaves in ways that defy our daily experience. Because it has much less mass than Earth, its gravity is significantly weaker. If you stood on this cratered surface, you would weigh only 1/6 of what you do now. This diagram tracks a movement we can't see from the ground. Every year, the moon drifts 1.5 inches further away from Earth. Even the moon, which we see every night, follows its own peculiar logic. If our closest neighbors are hiding these kinds of surprises, the objects further out operate by rules we're only starting to map. Once we move past the moon, we enter deep space, an environment characterized by a total lack of an atmosphere. Without air molecules to vibrate and carry energy, sound waves cannot travel. In this vacuum, even the loudest noise would result in absolute silence. You could be watching the massive kinetic energy of a stellar explosion like this one, ripping matter apart at thousands of miles per second, and you wouldn't hear a single thing. This silence defines the journey. Stepping off Earth means leaving the world of sound behind and entering a void where our most basic senses no longer apply. Beyond the void, the planets in our solar system exist in a state of thermal extremes. Our first stop is a world trapped under a thick, suffocating atmosphere. This is Venus. The surface temperatures here reach 900 degrees Fahrenheit, hotter than a conventional oven. You could bake cookies directly on this mottled ground. At the other end of the solar system, we find the opposite extreme, the smooth, light blue sphere of Uranus. Here, temperatures drop far below anything experienced at Earth's North Pole. It is a world defined by a level of cold that makes human survival completely impossible without heavily specialized protection. These planetary environments show us that the conditions we enjoy on Earth are a rare anomaly in a solar system of hostile extremes. Despite these challenges, Mars remains our primary target for exploration. Even when Mars and Earth are at their absolute closest, the journey there takes between 6 and 9 months. To put that 9-month window in perspective, it is the length of an entire school year. A crew would have to carry every meal and all their life support supplies for that entire duration. While extreme temperatures are a major hurdle, the sheer physical distance of space remains the most difficult barrier to overcome. As we move into the deep reaches of the galaxy, we find objects that function like massive cosmic vacuum cleaners. Black holes possess gravity so strong that they pull in everything around them, including light itself. Because no light can escape, they are completely invisible to our eyes. We only know they exist because we can see the way their gravity bends the light of the stars behind them. This image captures a tiny fraction of the universe. Each point of light here represents an entire galaxy containing billions of stars. To understand this scale, imagine counting every grain of sand on Earth, every beach and desert, then multiplying that by 1 billion. Across this vast number of stars and planets, the mathematical likelihood of finding a world with the right conditions for life becomes nearly certain. It leads to the inevitable question of whether something else is out there in the dark, looking back across the void at us. The silence we found at the start of our journey is the environment where we are beginning to find these answers. We are just starting to understand the scale of what is out there.